Step into rediscovery, where cosmic marvels and the magic of science come alive. Have you ever looked up at the night sky and wondered why astronauts can't see stars in space? It's a question that has puzzled many. You might think space would be full of twinkling lights, but it's not always that simple. The reality is quite different. Astronauts often see a dark sky, even with billions of stars out there. The vastness of space can be deceiving. Several factors affect how we see stars from space. It's a complex interplay of light and perception. These include how light travels, which can be influenced by various elements in space, the brightness of the sun and spacecraft, which can overpower the faint light of distant stars, and how our eyes adjust to light and darkness. Our vision is not always equipped to handle the extremes of space. Let's explore these factors to understand this intriguing phenomenon. It's a journey into the science of light and vision. Imagine you're an astronaut floating in space. The experience is both awe-inspiring and humbling. You're surrounded by the blackness of the cosmos, a darkness that feels almost tangible. And it's darker than the darkest night you've ever seen on Earth. The contrast is striking. That's because Earth's atmosphere plays a crucial role in how we see stars. It acts as a lens, enhancing our view. On Earth, our atmosphere acts like a giant lens. It scatters sunlight, making the sky appear blue during the day. This scattering also makes faint starlight visible at night. Without it, stars would be much harder to see. In the vacuum of space, there's no atmosphere to scatter light. Starlight travels in straight lines without being scattered, making the background appear incredibly dark. This lack of atmospheric scattering is one of the main reasons why stars seem to disappear in space. Think of it like shining a flashlight in a dusty room. The dust particles scatter the light, making the beam visible. In a clean room with no dust, the light beam is much harder to see. Another challenge for astronauts trying to see stars is the glare from their spacecraft and the sun. This glare can be so intense that it almost blinds them, making it difficult to focus on the faint light of distant stars. Spacecraft, especially those with metallic surfaces, reflect a lot of light. This reflection can be dazzling, creating a bright halo around the spacecraft that can obscure the view of the stars. This reflected light can be incredibly bright, especially when compared to the faint light from distant stars. The contrast between the bright reflection and the dim starlight makes it almost impossible to see the stars clearly. The sun, even from millions of miles away, is incredibly bright in space. Its light is so powerful that it can wash out the light from stars, making them nearly invisible to the naked eye. Its light can overpower the faint light from stars, making them nearly impossible to see. This is a significant challenge for astronauts who rely on star navigation. This is similar to how car headlights can make it difficult to see stars in the night sky here on Earth. When you're driving at night, the bright headlights can obscure your view of the stars. Imagine trying to see a firefly next to a spotlight. The spotlight's brightness would make it nearly impossible to see the firefly's faint glow. The spotlight's brightness would make it nearly impossible to see the firefly's faint glow. This analogy helps us understand the difficulty astronauts face when trying to see stars in the presence of bright light sources. The same principle applies to seeing stars in the presence of the sun or spacecraft glare. The intense brightness of these light sources makes it a real challenge to observe the faint light of distant stars. Eyes adjusting to the cosmic ballet. Our eyes are amazing organs that can adjust to different light conditions. They have the ability to adapt to a wide range of lighting environments, from the bright light of day to the dim light of night. However, it takes time for them to switch from bright to dark environments. This process, known as dark adaptation, involves the regeneration of photopigments in the retina. When astronauts are exposed to the bright light of the sun or their spacecraft, their eyes adapt to that brightness level. This adaptation is crucial for their safety and ability to perform tasks. This adaptation makes it difficult for them to see faint objects like stars. The bright light overwhelms their vision, making it hard to detect dimmer celestial bodies. Their eyes need time to adjust to the darkness of space and become more sensitive to faint light sources. This process is essential for navigation and observation in the vast expanse of space. This adjustment period can take up to 30 minutes, and even then, seeing stars might still be challenging. The eyes gradually increase their sensitivity to low light, allowing astronauts to see more details in the dark. Think of walking into a dark room after being outside on a sunny day. Initially you might not see anything, but slowly, your eyes adjust, and you begin to make out shapes and objects. It takes a while for your eyes to adjust, and you gradually start to see objects in the room more clearly. This gradual adaptation is similar to what astronauts experience in space. The same adaptation process happens with astronauts in space. Their eyes slowly become more sensitive to the faint light of distant stars, allowing them to navigate and explore the cosmos. Orbiting our way to stargazing challenges. The way spacecraft orbit Earth also affects star visibility. Many spacecraft orbit at high speeds, causing the stars to appear as streaks of light rather than pinpoints. This streaking effect is due to the relative motion between the spacecraft and the stars. The faster the spacecraft moves, the more pronounced the streaking effect becomes. This motion blur makes it even harder to distinguish individual stars and appreciate their faint glow. Imagine looking at a stationary object while riding a fast-moving train. The object appears blurry due to your motion. The same principle applies to astronauts viewing stars from a rapidly moving spacecraft. Stars, there, but hiding in plain sight. So, while it may seem like astronauts can't see stars in space, it's more about the challenging viewing conditions than the absence of stars. The lack of atmosphere, the glare from the sun and spacecraft, and the time it takes for their eyes to adjust all contribute to this phenomenon. Despite these obstacles, astronauts have captured stunning images of stars from space. These images often involve using long-exposure photography techniques that allow more light to reach the camera sensor, revealing the beauty of the cosmos. So the next time you gaze upon a star-filled night sky, remember that those stars are always shining, even when hidden from view in the vast expanse of space. Thanks for tuning in to Rediscovery, where every journey reveals awe-inspiring wonders. Tap that like button, share your thoughts in the comments, and subscribe to keep the exploration alive.